my usual silly self, but it's fine. Right, so let's get my thing set up. We are good. Well, hello everyone. If you are new to having me, which I think pretty much most of you are, my name is Donald Robertson. What I'm going to do today, I guess for the first 20 minutes, hopefully no more than that, is go over the gist of the syllabus and what's expected of you and what's going to happen in the coming term. And after that, the second half of today's we'll actually get started in doing the good stuff. But everything that I'm going to talk about is printed somewhere, so you don't need to frantically write things down. You can find them. First thing, I hope, let's just double check on that. You should be looking at our Canvas page. Is that right? Okay. So what I'm going to show you is what we have as resources. These are things that you can choose to use or not. We'll start on with the top one. This is a little information sheet telling you a little bit about me.
I've got a quick question. Your class is not showing up in my Canvas yet.
When did you join the class?
Over the weekend, I registered for it.
It may not have been processed yet. Okay, so hang in there. If it hasn't happened with, you know, say by sometime tomorrow, shoot them an email to remind them. Okay. They may be looking for prerequisite check. Have you done that check yet?
Yes.
And it came through fine?
Mm-hmm.
Right, if you don't get through, say by tomorrow, if you shoot me an email with, say, a photocopy of the prerequisite thing, I'll process it for you and send it to a person I know who can do it a little bit quicker. Okay?
Great, thanks.
Right, if anything that I'm doing because you cannot see it because you're not in Canvas, if you shoot me an email, I can send you a PDF that at least gets you into WebAssign and you can get started on the homework. Right, so I can do that as a cover, but you need to send me an email because I have 100 things going on right now and I'll forget. I just
sure.
Right, so that one is a little bit about myself. I was saying I started teaching in August of 1980. So I've been doing this job for a long time. I don't have too many years to go, but I'm still enjoying it, so that's good. If you click on this one, it gives you that information. If I scroll down a little bit and you click on that one, it takes you through how to set up WebAssign. This class is essentially broken into two distinct things. On Canvas, all you'll find there are resources, videos to watch, you know, extra videos to watch, videos of this class, because I tape them all, right, and put them on Canvas, PDFs of worked examples, you know, all sorts of stuff like that. So it's a kind of resource. And then the other half is on WebAssign, which is basically where all your homework and assignments get done. So that's your online stuff, your homework, most of your tests are going to be on WebAssign, and resources, videos to watch, things like that are going to be in Canvas. So they kind of separate nicely. If you click on this one, what you'll get is the link to this class, which is the one you're using right now. It's that link. That link will be good for about 4 weeks, and then I'll have to change it because you only get so many weeks in Zoom, and then you have to change links evidently. And here is where I'm going to be recording all of our lessons here. So for instance, Mondays will end up there. Don't expect it right away. I have to do a fair amount of processing, cutting bits out and so on. So it's likely to be on late tonight, but more likely early tomorrow morning. So there'll be a kind of a lag there. If you miss a day because you're at the dentist, this is where you can go and watch the lesson that you missed. If you're getting ready for a test and you want to say, whoa, I'd like to go over that stuff in week 1, you know, you can come here and find out what that's going to be, right? And that's pretty much what is going on there. Taking its time. Come on, you know, there we go. Office hours are at 10 o'clock. That's the Zoom link. So you just basically click on that. I'm here and I'll have my Zoom up and you just join. This thing called Microsoft Lens, we'll talk about that when you need to. This one here is some fun stuff. I put it there because I like it. Since I'm Scottish, I'm allowed to dig a little bit Americans. So I don't know if you can see this one well. I'll try and enlarge it. I kind of like this one. It's a kind of, we are very arrogant Scottish people, but that's because we're so good. There's Marines training. And there's the Scots guy training. Just to give you an idea. As time goes by, you will realize I have an atrociously bad sense of humor. But I think it's fun. So, okay, let's do it right now. How many psychiatrists does it take to change a light bulb? Only one, not only one, but the light bulb has to want to change. Right, so are you getting used to my bad jokes now, right?
I like it.
Okay. Yeah, okay. I also distract myself totally, but that's fine. This link at the bottom is WebAssign have produced a video to help you to get on to WebAssign. So I put it there in case my version of that, which is this link here, isn't clear enough. That's Calc 1 stuff here. If I now go into Calc 2, what you have here are basically the chapters that we'll be doing. If you click on this one here, it's a PDF, or it should be, of some questions. Right, so I've went over some questions. For instance, this is an example of a question. And that's one way to help you. If you click on here, I have videos on, and these aren't, these are not my videos, but these are just other people's videos that I've got from YouTube that I kind of like the way they do it.
Good.
It's helpful if you get to see more than one way of looking at something. I find that other people see it in a better way than I will. And I have no problems with that. So it's just a resource, right? And so you can see, you know, if you want to find out about a thing called rates of change, here are some videos on it. You can see how long they last so that, you know, if you watch this one, it's going to be a 4-minute video. If you watch this one, it's a bit longer. So you'll be able to tell just by looking how much time it would take you if you wanted to use that. So that's what I'm calling class resources. And the one called college resources is really for you to look at. It tells you all the good stuff. For instance, if you don't have equipment, you can get loaners from the IT people, right? They'll give you a webcam or something. But I would suggest that you get your order in quick because there's probably hundreds of people in the same boat. Any questions about that so far? Are you comfortable with Canvas as a resource? It just has stuff that hopefully will help you, but you can choose to use it or not. It's up to you. We good? Right. Let's look at the syllabus then. First thing is, when you communicate with me, will you use my email address, drobertson@olympic.edu? Or you can do it through Canvas. You know, you can send emails from Canvas. Those two work fine. Don't use WebAssign. WebAssign has feature like Ask the Professor. It's a little button that you click and you type stuff in.
Yeah, exactly.
I never see that. I don't know where it goes, but I never get to see it, right? So maybe one day I'll spend a day and figure out where the heck the setting is so that it gets re-forwarded to me. But just send me an email saying, I'm in trouble with question 5, right? Or turn up to office hour and we'll go over question 5, right? We can do that. Or I need an extension to the homework because I won't be finished on time, right? That kind of thing. That's up to you to just shoot me the email. So keep away from ask the professor or ask for an extension. Just type in an email asking for those things and I'll do it that way. because you might end up thinking I'm ignoring you, and it's really I just don't get the things. Prerequisite, I'm assuming you're here. If anybody is on the wait list, what you need to do to me is send me proof of prerequisite, right? You did AccuPlacer, or you got Math 142 and you got 3.7, right? That kind of thing. Also send me your student ID number, and I'll verify that it's correct. And if it is, I can then shoot an email to a person I know in the college who will set up, who will get you into the class, right? So it'll be set up, right? So if you want to do that, I've forgotten your name now.
Yep.
If you want to do that right at the end of today, I'll just put that in process, right? It's, you know, I'd rather have two people trying to fix it than nobody, right? So if we get one of the two, we'll get it done.
I have a question about that. If I'm just automatically enrolling in the very next class, would the system just not automatically say, oh, look on the transcript, already Math 142, that kind of thing?
That's what I was going to ask.
Yeah, it will do that. If you did 142 at Olympic College and you got better than a 2.0, the computer recognizes that and you will get in for that reason. But the class has a class size limit of 25. And so what they do is that you get blocked because of that. But when they block that, I don't know that you've got those things. So I have to check them. So, and if I check them, I'm the person who then says over enrollment. Say, contractually, I don't need to take anybody over 25 students. So I choose, because I don't want to not make you, well, I don't know what a phrase. I just don't want to stop you from getting in, but I need to verify it. So I don't know if they're ever going to fix that. It would be really nice if they could, in which case all I would need to do is say, let Rachel in, but that's not the way it has to work. I have to see your prerequisite. And it's not hard. If you've did 142, can't you just show me a screen grab of your grade and your student ID and we're good to go.
Okay, good.
Right. Now, if you're in the first 25, none of that's a problem. You got in automatically, right? So you didn't have that. So I guess, Rachel, did you join late and end up in the wait list or something?
No, I was just making sure that I wasn't going to get a surprise.
No. If you're in the first 25, the computer's already done the check. I don't need to check it.
Okay, good.
Okay. Right back to this. You need videos. You need good computer. All that good stuff. There's that link. I hope it's still active, where you can ask for support. I need a webcam. I don't have one. You can actually get, I believe, computers, laptops, all sorts of stuff. Don't need a textbook if you pay for WebAssign, right? You get an ebook there, so you don't need a physical one. It's still expensive, but textbooks are. Here's the same information, but an abbreviated version of how to join WebAssign. Here is our calendar. 2 holidays. Monday the 17th is Martin Luther King Jr. Day, and Monday the 21st of February is President's Day. Those will be holidays, so no classes. The other important dates for us are the midterm on Monday the 7th and our final, which is on Wednesday the 16th. Okay, they're the important days. Now it moves on to the WebAssign. So I'm going to jump to another spot here. Is it this one? Yes, it is. Right. So once you've joined WebAssign, it will look something like this. The course is broken into 10 weeks. And in each of these weeks, you've got a certain number of sections of work to complete. And they're always due on midnight or 11:55 p.m., close to midnight, right? On Sunday. And when you go through these guys, this one here is just a simple getting started in WebAssign. So if you've never done WebAssign, it kind of takes you through some of the things. Let's pick one let's pick this one and show you what homework would look like. So don't worry about the fact you don't know the answers yet. We will cover it this week, so you'll eventually get to do the answers. But you can see in this question here, they tell you a little bit about what's going on. In this one here, there's a video example. If you click on it, there'll be a short video. And here is the question, all sorts of stuff, and then fill in the blanks. And boom. Oh, my apologies. Yeah. Unfortunately, since I'm not a student, they tell me the answers. Those are the answers that you will be typing in. Do you see those red guys?
Oh.
Those will be, you wouldn't get that. That'll be blank. You'll be doing some answers there, I believe. And, good. Answers go in here, 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 and here, right? And let's suppose I have no idea what the answer is, but I think it's 52. If you've done the thing, you can hit submit answer. If it's correct, you'll get a little green check mark. If it's wrong, which I'm sure this one is, it will tell you eventually. There. And it tells you a little feedback. Oh, maybe you should look at this again, right? And you can hit a watch it and you can have it a read it. And so if I hit the read it, I've got a lot of windows open, so things are a little bit slow. I won't register for that, right? It takes you to the ebook and it takes you to essentially the place where that question belongs. And then there you go. So you can read over some stuff. So that kind of makes sense how you're going to do your homework, right? So you do a lot of the working, but all they typically ask you to do is to put in the answer 42, 11, you know, watch a video, fill in some workings, and so on. Right. So
and for the homework, we can try it as many times as we want.
You get 5 shots. That's it.
Okay.
So you have four shots, all wrong. 5th shot is good. Since you know when you've got the right answer, you stop, right? Because it'll have a green check mark, or a tick mark, whatever you call it in America. Are we good?
Is there going to be like a time when we would need to show our work or take a photo or anything like that?
Yes, but not on this. So when you're doing your homework, I don't need to see working. Since there's only 5 guesses, the chances that you guess correctly are pretty slim. So if you got the right answer, you probably were doing it correctly, right? It's not a biggie. But you're right, there are going to be situations where that will happen. And that's probably a good lead into what's going on. So can you see that week 1 is going to be do this stuff? And then this fella. Online test 1. Every week there's a test. And the test is on website. And it'll probably be called something like online test 1. It won't appear until Saturday. And when it does appear, anytime between Saturday midnight and a minute into Saturday, all the way to about 10 o'clock on Sunday, you can do it. And you click on it just like normal homework. But there are some differences. The first difference is that once you click on it, you've got 90 minutes to do it. So it's a time test. It's a bit like, oh, I've got a test for you. Drop by my office anytime you like. And when you drop by it, I hand you the test and I say, you got 90 minutes to give me that back, right? It's kind of the online version of that situation, right? So anytime you want, if for some reason you can't sleep and you do it 3 a.m. on a Saturday, go ahead, go for it, right? But the minute you click on it, you have 90 minutes. So do not click on it until you're ready, right? Because the clock doesn't get rewound or freeze, right? If you leave it, it don't care. It's still ticking. So be careful about that. That's one of the reasons you won't see it is it there? Here. Well, wind back. That's why it doesn't appear until Saturday, because I don't want you accidentally thinking it's some homework. And homework is due by midnight on each Sunday. So that's week 1. This is what we'll do week 2, week 3, 4, and then we have a midterm. And the midterm is connected to what you were talking about, Rachel. Up to this point, nothing needs to be sent to me. You don't need to do working, although I'm assuming that you need to do it because you need to get the answer, but I don't need to see it, all right? But the midterm's going to be different. You're going to turn up to class just like this. And you are going to have a PDF with questions, right? A PDF like on the screen in Canvas. And you are going to get it sent to me. And we're going to use a program, although you can use other programs if you're used to them. Microsoft Lens is the one we're going to use. Basically, you take a picture of all your working for the test and you send it to me and you upload it into an assignment called Test 1, probably. And so that's the only time I will be saying working will be in week 5. And then the same thing happens on the final. The final will be in Canvas. So that's the only 2 times assignments are not in WebAssign. The midterm will be on Canvas as a PDF and the final will be on Canvas as a PDF. And those you'll show me working and you upload them and I grade them. Kind of like you would do in class, right? You finish the test, you hand me the paper, I would grade it, right? That's how that's going to work. Are we good? Yes.
So okay, so it'll unlock or something at the right time and
Yeah.
then we'll,
You'll turn up to class like right now
okay,
and I will unlock it and it'll suddenly appear in Canvas.
okay.
And then when time's up, I'll lock it and it'll disappear from Canvas.
I'm sorry, and then how long do we have to work on it?
I'm still trying to figure out a schedule on that. You're guaranteed the 50, well, say the 1 hour that this class lasts for. But I'm trying to see if if it's possible for me to do maybe an extra hour either side of this. It depends on everyone else's schedule. If you can, if I find it works for you, I might say, okay, it'll start at 11, but it'll finish at 1. In fact, now that I've thought about that, let's pause for a minute. Right, do you know that you've got a little thing here where you can put reactions, it's called, in mine? Right, I'm going to put a little thumbs up. Do you see it? My little thumbs up, right? Now I'm looking for thumbs down here. I don't want to see any, but that's what I'm going to check for. Is 10 a.m. bad for you? Thumbs down if it's bad for you. I can't do 10 a.m. So if I make the midterm 10 a.m. to 12 p.m., you're cool with that. It's not going to interfere with anything else. Okay, Jessica, it does interfere with you? Is that what you're saying?
No, it would interfere with me. I have an in-person class like in the middle of that time.
Right, we can arrange a 1-person fix is easy enough to do. Could you do a 1 p.m.?
I could do 1 p.m.
Right, so that's not going to be a problem. Everybody, Andrew, what you got for me? You got a 10 problem as well?
Yes, I do.
What's a 1 p.m. like?
1, I think, is okay.
Okay, so basically most of you are just going to do the 10 to 12 and some of you are going to do the 11 till 1, right? Does that seem fair?
I mean, I can't start until 1.
Well, you have to be here at 12, right?
Oh, yes. I see. Okay.
Right, so it'll be 12 and you'll finish at 2 o'clock, right? You'll get a 2 hour.
Okay, got it.
Right, I think that's worked out well. So you really, I'll be flexible, right? You either turn up at 10 and you have the 2 hours from 10 till 12, or you turn up at normal class time 11 and you finish at 1, right? So you'll get a 2 hours slot both ways. Does that work for you?
For this, you need video access, is that right?
Yeah, when it's a midterm and the final, I definitely need to see you all. In fact, I should be seeing you all right now, but I'm assuming you're still getting used to technology. For lots of reasons. One is I want to make sure nobody's cheating, right? So Teresa, I don't want your twin sister behind you pointing at the answers and telling you what to write down, right? Not that you would ever have a twin sister or that you would do it if you had one. But, you know, that's one of the things. It's a security thing
Okay.
to make sure everybody's getting treated the same way.
I'll just have to, I have to leave work to get video access, so I'll have to figure that out.
Right, that's going to be two, I know it's a pain in the butt, but it's going to be two different, at least you know when. So
Yeah.
if you can, you know, you can get your boss to give you a little window and come back and then another window for the final. The final's 3 hours, so that might be the whole day, probably.
Okay. Thank you.
But yeah, the final's a fixed time, so everybody will be fine with that one. I think we are on the final one, or we may not be. Let me check. Right. So can you see the final exam now? Is it on the screen? Okay. Well, this class is basically the intro to Calc 1, and I'll go into that after we finish this. But here's the learning objectives. Don't cheat is that one. If you have some issues, talk to me about it. And now the grading. 10% is on participation. So let's tell you how that works. You are here. That's participation. You need to turn up. It's mandatory. And 10% of your grade is based on that. And the way I check that is very simple. Do you know at the bottom you've got a thing called chat? I want you to go to chat and just put in your last name. So Corbin, just put in Hyatt. Don't put in your first name. It's awkward for me, right? And Jessica, just put in Townsend, right? And that's it. That's you. Basically, I've taken attendance. And what I do is I take that file and I put it through some Excel stuff and it kind of counts attendance for me. Okay, so that's attendance, 10% of your grade. 25% is based on your homework. Another 20% is based on those tests that we talked about, right? Those online tests, 20% of your grade. The way it's going to work is you do 10 of them, but I throw out the 2 worst ones. So if you have a couple of really bad ones, they don't matter because I won't count them. The midterm's 15 and the final is 30. And then there's 2.5% on your grade, which is just extra credit. Every homework that you do, right, the 10 weeks homeworks, every one of those that you do and do not ask for an extension, you get 1/4 percentage point added on to your grade. Well, it might not mean much, but you know, 2.5% could be a 2.1 to a 2.3, which is okay. But it could also be a 1.8 to a 2.0, which is really important, right? So it could help you pass. So it is an advantage. And the rest of the details are here. So you probably better to read it over and then ask me tomorrow some questions if there's things that don't make sense. But is there any questions right now that you'd like me to clarify before we start class? Okay, let's get started then. We are eventually going to do it. So this is us, Calc 1. The first one in 4, well, for some of you, 4 calculus classes. Calc 1 is to do with differentiation. Calc 2 is basically integration. Calc 3 is a mishmash of all sorts of stuff, mostly 3D and space curves. And Calc 4 is multivariate calculus. So that's what the Calc stream looks like. If you intend to become an engineer, you probably will do all of them. So our first section, 2.1, deals with what's called the tangent line problem. So I'm going to get a little bit of history behind it before we get into the homework and the details. This was a long-term problem that was tried to be solved by many mathematicians. And basically it says, suppose I got a function y equals f of x, right? Y equals x cubed minus x squared, right? That kind of thing. And I was interested in the slope of the tangent line at some given point P. Now, if you're not sure what a tangent line looks like, it's basically that line there. Do you see that green line? A tangent line is a line that just touches the curve, right? It doesn't cut it, you know, pop through it and then cut through somewhere else. It just glances like that, right? Just tangent line. And we would like to know the slope of that tangent line. And that is called the tangent line problem. And it might not seem like a biggie, like, well, how hard is it? Well, couldn't you just draw the curve and get out a ruler and draw a tangent line and then do a kind of rise over run, you know, that kind of thing? Wouldn't that do the job? Well, no, not accurately, because wouldn't Rachel's green line be very likely be just a little bit different than my green line and Corbin's green line? Can you imagine when you draw a tangent line, there's going to be some wiggle, isn't there? I mean, who's to say which one of us is right? So that technique gets through out pretty quickly, right? You can't just do it by drawing it. And we'd like to know what that slope is. And it's a unique answer. In other words, there's not a couple of answers and they're all right. There's one answer. The problem is we don't know what it is yet. So what they did is they tried to find some techniques for coming up. And the techniques that they used, the first one, is that they did a numerical estimate. That's essentially the way an engineer would approach it, right? It's not the perfect answer, but it's darn close, right? It's correct to 8 decimal places. Isn't that as good as any human wants anyway, right? That kind of thought process. No, it's fine for what it does. And then the second method they used is that they use things called limits. And we use limits to find out the exact value. And that's where calculus and what we call derivatives comes in. A derivative is just another name for the slope of a tangent line at a given point. And then from here, they developed a shortcut. And we developed techniques for finding the slope of the tangent line by using algebraic methods. These are basically rules, and these are just some of them. There's a rule called the power rule. There's another one called the product rule. And I won't write the rest down. You'll eventually get to see all of these. You've got product rule, quotient rule, implicit differentiation, logarithmic differentiation, trig derivatives, and all sorts of other cool stuff. And that's pretty much a main chunk of what we're going to do. And then the last thing we're going to do is, once we've figured out how to find slopes of tangent lines, we're going to do applications. In other words, how can these derivatives, slopes of tangent lines, help us solve problems? And the kind of problems that it's going to help us solve is it'll allow us to find things like velocity and acceleration of moving objects. It will allow us to find optimum values for problems, like what's the most efficient size you should make a box that doesn't have a lid if you've only got 10 square meters of material. Where should you put a pipeline to minimize the cost? Cool things like that, applications. So let's start with numerical estimates. So I'm going to use a guy that you should have met before, or you may have forgotten it because it was in 141. we are going to use a thing called the average value of a function. So let's just spend some time working on this and then we'll return to numerical estimates. Let's remind you what that is. Suppose you have a function y equals f of x, and you want to find the average value from x equals a to x equals b. The average value of a function, very often called FAVE, short for function average, is given by a formula. Okay, I'm putting you on the spot. Anybody gets this deserves brownie points. Can anybody remember the formula for the average value of a function y equals f of x from x equals a to x equals b? Any chances? I don't care if you get wrong, then go for it. If you think you're half
Is
right,
it
go.
y2 minus y1 over x2 minus x1? Does that make sense?
That does make sense. And it is sort of a that, but I'm going to replace each of these by things that use these guys. So it is essentially the same thing, but it's not going to look that way. y2 is just going to be the function of the value of the function at b. Take away y1, the value of the function at a. And b, take away a. Now that I've written that guy down, is it a little bit more familiar? Do you say, oh God, that was ages ago. I think I remember saying that. Or, nope, I can't remember what I had for dinner yesterday. So 6 months ago, that's something else, right? Well, that's your new go-to guy, right? He's back in, right? You've opened the door, you've put the formula in. Let's use them. Let's suppose I have a function y equals x squared plus 3. And x is 2, right? From x equals 2. And it's going to finish at x equals 4, right? Then I want to find the average value, right? From here to here. So the average value is going to be the value of the function at 4, because that's basically b. Take away the value of the function at 2, which is basically that guy, all over 4, take away 2. Now, if you plug in 4 here, you get 19. If you plug in 2 here, you get 7. And this guy's 2. So what do you get? 19 and 12, you get 6. And we call that the average value of the function from x equals 2 to x equals 4. So far, so good? A little bit more familiar? Now, how's that going to help me get a slope of a tangent line? Well, let's draw a little picture, not particularly accurate, of what x squared plus 3 looks like. That seem reasonable? You could have plugged in your calculator, right? That's roughly what x squared plus 3 looks like. Now, I am interested in finding an estimate for the slope of the tangent line of this function at x equals 2. So can we pretend that x equals 2 is there, and I'll put a p on it, right? And we are going to use average value of a function, because when you look at this formula, isn't this basically rise over run? And isn't this the slope of a line joining the point with x coordinate A to the point x coordinate B. So I'm going to set up a little table here. And we're going to have x. And we're going to have the slope joining P to Q. Now P is going to be the x coordinate of 2 and 2, 7. And I'm now going to choose a Q, which is really just some other point over here. And it's 4. So I'm going to have from x equals 2 to x equals 4. And the slope of the line joining P to Q is the same number as the average value of the function. So isn't that nice that that and that have the same answer? And we already did this one, it's 6. And now I'm going to do x equals 2, right? So that's fixed. But I'm going to change it to 3 now. So move over here. What's the slope of P to Q going to be? Well, it's going to be the value of the function at B, take away the value of the function at A, over B, take away A. And since that's going to be my A and my B again, it's going to be the value of the function at 3, take away the value of the function at 1, 3 take away 1. Right, the value of the function at 3 is 3 times 3 is 9, that's 12. Take away 2, why am I saying that? That's a 2, my apologies, that's better. The value of the function at 2 then is 7, and that ends up being 5. So I'm going to put the answer 5 in here. And then I'm going to do x equals 2 to x equals 2.1. And I'm going to find, essentially, can you imagine what I'm doing here is I'm finding that slope, and then I'm picking this guy and I'm finding that slope, then I'm picking another one. As you choose the second guy, the guy we're calling Q, do you notice if you move him really close to P, won't the line joining P to Q be dead similar to the tangent line because the P and Q are so close to each other? That's the trick to how this works. So I'm going to do a 2 to 2.1 now. So 2.1 take away 2 over 2 take away 2.1. Now I could do each one of these calculations in my head, and if that's going to work for you, just do that. But I'm lazy and I'm also careless. So I'm going to show you how I would set this up on my calculator. I go y equals, don't know what that stuff is, gone. Type in the function, which in this case is x squared plus 3. That was easy done. And then go second table setup. I'm going to start my table at 2. And I'm going to change this guy to ask. Now, the reason I'm starting at 2 is because the P is 2. And the ask is going to be allowing me to take the other fill in. So it's ready. So I just need to do second table. And I'm going to put in 2.1. And 2.1 gives me 7.41. That guy is always 7. And what do I get? I get 0.41.
Someone asked if the denominator was backwards.
And you're right. But luckily I did it correctly this way. And I get the answer 4.1. Now, can you imagine I could do this forever? But I'm going to just do it one more time. How about x equals 2 to x equals 2.01? Would you agree that that is darn close to being on top of it? right? So shouldn't the line joining these two be very close to being the guy that we want? So here's my estimate. It's going to be 2.01 take away f of 2. And whoever went and told me, the person in the chat, thank you very much, because I don't have enough windows to see what's going on in my chat, essentially. 0, 1. And this time I get 7.0401 take away 7 all over 0.01. And this ends up being 4.01. And I'll put the number 4.01. As we travel downwards, we get more and more accurate estimates. If you were a gambling person, what do you think the slope of the tangent line probably will be?
Somewhere around 4.
I would agree with you. Does it seem reasonable? It's probably dead close to 4 or 4, right? Haven't we now found the solution to the tangent line problem? Numerically estimating. You see how we do this? Average value, which is the same thing as the slope joining 2 points. And by bringing the second point, the Q, closer and closer and closer to P, aren't we going to get much more accurate answers? In fact, if we were really lucky, wouldn't we do away with all those ones and just pick a couple of numbers like 2 to 2.01 and 2 to 2.0001, right? Because wouldn't they be the only ones that really are important for the estimating?